Okay, so in this lesson, we're going to look at Chapter 7.1 and 7.2, limits of trig functions and derivatives of trig functions. So that's what we're going to look at here today, limits and derivatives. Now, if you remember back to Chapter 1, we talked exclusively about limits, and then we kind of described some of these limits as derivatives, right, in Chapter 2. And so limits and derivatives obviously are very closely related. If we look at 7.1, there's just a few things that I want to outline from 7.1. And the first is the limit, okay, as theta approaches 0 of a sine function, okay, of sine theta. So what we've learned already in the past is we know the general sort of, I guess, outline or the general sketch of a sine graph, right? Looks like this. And here's pi here, here's 2 pi, right? So this is sine theta. If we extended it back the other way, right, we would have this here, back up there. Okay, so this would be a negative pi here. Not exactly to scale, but what I want to focus on is this kind of middle area here, right? If we're talking about a limit, and if we're talking about what happens as theta approaches 0. Now, notice that it's not a one-sided limit, right? It's a two-sided limit. So what that means is we're looking at from both directions as x approaches, or theta approaches 0 from both directions, what does the y value center in on? And it's pretty easy to see here from what you know about limits that as theta approaches 0 from both the left and the right side, the y value gets really, really close to 0. Right? So it would be accurate to say that as sine theta, as theta approaches 0, for sine theta, the limit is going to be 0 itself. And that's what we see here. Likewise, if we're talking about the limit as theta approaches 0 of a cos function, we would simply look at the cos function, and just to save some space here, I'm going to erase this. You can keep that obviously in your notebook there, but get rid of some of these arrows as well. The cos function looks like this, right? Yeah. And so this is cos theta. That's what that graph looks like. And you can probably pretty easily see here that as x approaches 0 from both sides, that the y value, okay, from this side we're approaching this value up here, and from the left side we're approaching this value up here, and that is y equals 1, right? And so the limit for the function of cos theta as theta approaches 0 is 1, because that's where the y value is, y equals 1. All right, so just a reminder about those basic functions. We could do tan as well, which tan is not really focused on here in this section. But if we did tan as well, a quick tan graph looks something like this. We have asymptotes. Do you remember where those asymptotes are? Not negative 1 and 1. No, well, in terms of in radians, let's say radians. So what angle? Like, remember this is pi here, right? This is pi over 2. So if we think back to the unit circle, right here, okay? Do you guys remember this from pre-calculus? Okay, you should remember this. And if yeah, if you're wincing and if you're grimacing right now, I can tell that you do remember it. That's great. But if you look at something like this right here, okay, 90 degrees or pi over 2, right? We know that we find the tan by doing sine divided by cos, right? And so the second value is a sine value, the first one's a cos. So here at 90 degrees, the tan is undefined, right? So that's at pi over 2, and then again at 3 pi over 2. So back to our page over here. This is going to be pi over 2, and over here would be negative pi over 2. Okay, that's where your asymptotes are. And so the limit as theta approaches 0 for tan obviously is 0 here as well. Okay, so this does round it out, although we're not going to really do too much with this. Okay, that's 0 as well. Okay, everyone got that so far? Okay with that? That's just going straight from the graphs, and just you get limits, like that's baby stuff, right? So you got this under control. The one thing though that we're going to capitalize on here, and there's kind of like one thing that's going to really help us to simplify limits, that if we know this, and it's something that you wouldn't really guess is true. To tell you the truth, it's kind of a little bit off the wall. But what I want to show you is this. Okay, if we have like a little bit of a chart here, sine theta and theta. Okay, so we're going to make a little chart here, and let's do let's do this in radians, but let's do like negative 0.5, okay, radians. Let's do negative 0.2, negative 0.1, and let's do then 0.1 and 0.2 and 0.5 plot. Okay. So actually, I just realized that I'm actually sorry about this, but I'm going to have to move the sign over here because I'm picking the theta values. So my bad. I'm going to have to erase that. But if we had negative 0.5 here, okay, and then negative 0.2 and 0.1 and so on. So these are sort of the values we're looking at. Okay. So what is the sine of negative 0.5 if we're talking about radians here, especially? Okay, here it comes, my calculator, there we are. You don't have to have a graphic calculator for this. You can have just a regular calculator. I'm going to check my mode. See, I'm on degrees right now on this calculator, so I'm going to go down there and make sure I'm in radians, and you want to make sure you are as well. Okay. And let's clear the screen off. Okay, so sine of negative 0.5 is negative 0.4794. All right, and let's do these as well. So 0.2 is sine of 0.2. Negative 0.2 is negative 0.19866. So if we fill out this chart here, we see that we have values like this. And what I'd also like to explore here is this right here. Okay, sine of theta divided by theta. So the sine of theta divided by theta, and just those straight numbers. And so let's try that. We have the first one is negative 4794, and of course this is in change, right? Like not the. There's the decimal up there. Actually, I'm going to copy that for. So 255,386 divided by 0.5 is going to be negative 0.9588. Okay, so quickly fill this chart out here. We realize that obviously these are all positive with a negative divided by negative, and positive divided by positive. These are all positive values. All right, so the interesting thing here is that if you look at theta approaching 0, okay, 0 would be somewhere right about here, right? As theta approaches 0 with these three values, what does sine of theta divided by theta seem to approach? We have 0.9588, we have 0.993, we have 0.998. What are those values seeming to approach? What would be kind of your logical guess? Yeah, it looks like it's approaching 1. Now from the other direction, from 0.5 going back towards 0, right, we see the same pattern, 0.9588 up to 0.9933, 0.9988. Okay, so let's see if I can do this. Ooh, wow, that worked pretty good. Okay, so let's just delve into this a little bit more. Okay, you guys over there, you three, why don't you do this one? How about 0.001? Okay, so you have to find the sine of that and then do that division. And you girls over here, why don't we do positive 0.0001? Okay, can we do that? Okay, so we squeeze a couple more values in here. We see that sine theta over theta is extremely close to 1, right? So yeah, so it seems like as we approach, 0 here, right? And as we approach 0 from the other direction as well, the values seem to be approaching 0. Now, we went through this whole rigmarole here because we can't substitute 0 right in here, right? Because sine of 0 is 0 divided by 0. So that's 0 divided by 0, which is totally meaningless, right? It's not infinity even. It's totally meaningless. It means nothing. So we have to examine sort of around that value, and that's what we've done. All right, so what this is saying is that the limit of sine theta over theta as theta approaches 0 is 1. That's what the limit is going to be. Okay, so this is another interesting limit that we can take advantage of here. All right, so what this does is this makes kind of strange limits doable. If we kind of, oops, that's x approaches 0. If we take a look at this, and let's say we have something like this, okay, over x. Now that's different, right? This is a theta, but that's half of that theta, isn't it? You see? Here's theta, that's double the theta, whatever, however we want to look at it. This is not the same case here. So it's not 1, right? It's not the same. But we can use this fact to, and you guys have actually, we've done this before actually. You might even recognize this, but what happens if we write this like, oh, I know, I can write that over 2x as long as I multiply a 2x in the denominator. So let me rewrite that. If you make it look like this, sine of 2x over 2x, and then you have this 2x up here. You see what we've really done is multiplied the numerator by 2x over 2x, right? Okay? And then what we can do is we see that, hey, I have an x up here and an x here. Those cancel out. Right? And so we have this. X approaches 0 of 2 times sine of 2x over 2x. And if you take the properties of limits, you can take the limit of x approaches 0 of 2, which is just going to be 2. And the limit of this over here, we know, is 1. So you can use that fact. You can use this property right here to calculate simple limits. I'll do one more example with you here. And again, we're not going to do too much of this, but just to show you kind of how this works. Okay, if you're asked to calculate a limit here, okay, well, if you just plugged x in, see, here's the problem again. Over here, you'd be dividing by 0. It would be 0 divided by 0. Over here, we would have sine of 7 times 0 is 0. So sine of 0 is 0 divided by 0. So you have a problem. How can we find the limit without actually graphing it, without actually doing pardon me, test values in a chart like we did before? You can use the fact that the limit as x approaches 0 of sine theta over theta equals 1. And this is what we do. X approaches 0. This is 7x times sine of 7x over 7x in the numerator. Do the same thing that we did in the last question. Multiply 4x by top end, what would be the bottom of this denominator, and you'd have 4x is sine of 4x over 4x. You see that? Do a little simplification, and the x's go. They are divided out there. Okay, and if I'll show this complete step here so there's no wondering. Okay, the limit as x approaches 0 of 7 times the limit as x approaches 0 of sine of 7x over 7x.